Hello, hello, hello. Good afternoon, Internet. Whoa. Oh, we're a bit off. We're a bit off. Welcome. Welcome to another NL Mathman Math Help stream. Oh boy. My chroma key is okay. Well, I'll just stay leaning forward like this. No one will be the wiser. We'll never notice. It's DIY. It's DIY FYI, right? For your information, it's do it yourself or do it myself or someone else has already done it, but it was done by themselves, right? It's tough conjugation for that one, is what I'm saying. Either way, holy moly. Okay, there we go again. So for whatever reason, I don't know. Is anyone in chat chroma key wizard? Let me tell you something. But for some reason, when I every day, every day it starts going different for these chroma keys. I don't know what's going on. And I've got another one turned back on. Okay, we're getting a little bit better. It's a bit better. We're making do. Still looks good, right? So, yeah, today we've got a nice background here over to the side. This is from this past winter, actually. Only this picture's only a few months old, so you're seeing the little furry people. They're Flurry and Smoky down there, over wait, over that way. There we go. Yeah, there we go. Down over there, two of them. It's pretty much yeah, it's pretty much the same as they look now these days because that's only like what 2 or 3 months ago this picture was taken. Yeah, I've actually shown this picture on stream before because this was the background to my desktop for a while. So you might have seen that in I think stream like 3 or 4, where I had my camera pointed toward my desktop. You saw this one with like some game icons on there, some like Civ 6 and I don't know Dark Souls 2 and whatever other uh, Slay the Spire and The Long Dark and various other games that I play. It is kind of like a scene from The Long Dark, right? Except there's a skidoo and dogs. Long Dark just has broken vehicles and wolves trying to kill you. Anyway, a dog in that game would be sick, right? If you got like a pet dog and you could feed it like fish or whatever to keep it happy, and then it would help chase off wolves and bears for you. That'd be sick. Anyway, Hinterland, Raf van Lierop, you could get on that one. Anyway, this is not NL game suggestion, man. It's NL math, man. But yeah, I actually showed this picture on stream before, and then my dad got wind that I was showing pictures of my dad. If you can see him here, you can see him just barely behind my head there. There he is, just bent over, closing the door on that shed. Anyway, oh, he's gone again now. Okay. But he got wind that I was showing some pictures on stream, and then he asked me to. He asked if I had shown this picture yet, because he wanted me to talk about his caboose, the caboose for the skidoo that he made. Hey, Slayer Darth. Yes, I am. I am. St. John's is where I live. I teach in a college near just outside St. John's, but I do live in town in St. John's. I have an aunt who used to work as a nurse in St. John's. Oh, okay, yeah, yeah, small world. Yeah, it's a nice place. There, it's a great spot for hiking, and yeah, yeah. I mean you know the weather can be a bit intense sometimes, as we found out earlier this year with Snowmageddon, which you might have seen about. A snowstorm that closed the whole city down for like 2 weeks. But hey, trouble is, as you know, St. John's kind of a remote place. Well, it depends on who you talk to and what your priorities are in life, right? Like I used to live in just outside of London in UK, not London, Ontario, right? The real London, not the discount London. And yeah, I mean that was obviously like the opposite of remote, right? Because London is like world hub and all that. But I don't know. I don't miss. I mean, I do like being able to travel around, right? Um, the hospital she worked at found it difficult to get doctors to move there. Well, if she worked in St. John's, she worked in the hospital in St. John's, which is called the Health Sciences Center. It is a fairly big hospital, which is attached to the university, Memorial University. I mean, sometimes, yeah. So international doctors, it might be more difficult to get them to move to town for sure. But perhaps after COVID-19 settles and people see how Newfoundland is crushing it for cases because we're an island and isolated and all that. Maybe people might realize how safe it is to live in a place like Newfoundland. But anyway, we're all in it together. We're all going to pull through for sure, right? And our social distancing is part of that for sure. Over here, though, I wanted to mention this Skidoo trailer that Dad built. Right, it's part of the motivation for the title on my stream. He built that himself. It's yeah, it's made out of plexiglass and an old bed frame and some PVC, I think, or some that he made the skis out of. Boy, it's got two separate axles that pivot. It's a real brilliant DIY project for sure. But that's what Dad does with his time. Always building new projects. Maybe I'll show you some pictures of his most recent project that he sent me, which is a box on the back of a side by side ATV to keep the dogs in when they go driving. Say, in talks with a husband and wife doctor couple to move for the hospital from overseas, I think from Australia. Okay, yeah, that'd be quite the move, isn't it? Although it depends on what part of Australia they were from, right? If they're from Tassie, if they're from Tasmania, the climate is not that much different, although a bit colder. Although if they were probably from like Melbourne or somewhere like that, they're gonna find the climate to be quite a lot colder than they're used to. I mean, St. John's is one of the snowiest, windiest, rainiest, foggiest, and cloudiest cities in Canada. Which puts us pretty high in the running for one of the snowiest worldwide, right? It's it's a land of mist and rain and precipitation. People talk about London fog, right? And I got to tell you, from living in London for about 2 years, or just outside of London, London fog ain't got nothing on St. John's fog. Like it's not even in the same ballpark. Like it's southern England, it's foggy occasionally. St. John's, it's like gray overcast is basically what passes for sunlight in St. John's. So these nice sunny shots. This is from the west coast of the island, right? Although I'm exaggerating. St. John's does get sun sometimes. Just you know, it is a land of weather extremes, that's for sure. Our temperatures aren't super extreme because we're a maritime climate, right? Um, so it's not nearly as cold as places can get in Canada, but the amount of snow we get is the highest of any Canadian provincial capital, which is it's pretty high. So yeah, what do I want to get to today this morning? I think this has been a pretty good intro so far. So I'm gonna switch on over then to some math related topics. We're gonna do Math 1102C Unit 2 test review. Got someone starting that one tomorrow, I believe. We're gonna do some 1102A Unit 3 test review, and I'm gonna recap a little of Math 3102A Unit 2. Okay, so systems of equations I'm going to get to first. So let's switch on over here. Actually, let me make sure that I've got my correct. Yeah, here we go. Actually, first I'm going to recap a little bit of there's a little bit from that same course that I want to recap. I'm going to get to that first. Okay, so let's switch on over here, document display. Here we go. Yeah, good stuff. Let me zoom in on my paper. There we go. Sorry about that. Don't mean to give you motion sickness there. Following my camera. Okay. So this is now Math 1101C Unit 2. And I want to do number 1 and number 9 from this activity. All right, just want to review these real quickly. So number 1 here over in the corner tells us, asks us, what is the slope of a line that is perpendicular to the line passing through negative 6, 2, and 7, negative 8, right? So our points are going to be negative 6, 2, and it's going to be 7, negative 8. Okay? Now we always know that our points are x comma y, of course. This is x, we'll call this x1, y1, and I'll call this x2, y2, right? And we know then to find our slope is, like we mentioned yesterday, right? It's delta, it's the change in y over the change in x, delta y over delta x, which is y2 minus y1 over x2 minus x1. So in this case, then, it's going to, we've already got those values assigned sort of over here, right? Y2 is negative 8 minus y1 is 2. X2 is going to be a 7, and then x1 is going to be a negative 6, like so, right? So I'm going to keep going across with it. I know I keep saying this. Across is not disciplined, and I do it anyway. So, what do I know? Listen to what I say, not what I do, right? So negative 8 minus 2 is going to be a negative 10. 7 minus a negative 6 is going to be a 7 plus 6, which is going to be a 13. Okay? So now we're looking for the line perpendicular to this one. Perpendicular lines, right? So this is the next part we need to know. Have negative reciprocal slope. So it's going to be 13 over 10, right? Because we've got our negative 10 over 13. Flip that guy around, 13 over 10. So this is going to be option D. Okay? So that is it's one of the two questions I wanted to get to on this activity. All right, one of the reasons I do up these is because I want to be able to show these are some sort of teachable moments that I'm seeing from work that I'm correcting for students. Because, like for example, once I'm done here, I I go and like correct things and send it off just like a you know just like what I would be doing if I was classroom teaching, right? So now we're going to go down to question 9. Question 9. Okay. So this one is, were those the ones you got wrong? Betty Ann, yes, you did. There were two here that I wanted to mention, and these are the two that I wanted to. You'll see um, I'm going to send you a more detailed breakdown as soon as we're done here. But yes, these are two that I just wanted to mention really quickly. Nice layer, Darth. Yeah, thanks for dropping by. But yeah, come on back and hang out whenever you like. Okay, so number 9 then. We've got y plus 3 is 2 outside of x minus 5, like so. And it's looking for the y-intercept of this one. So for my money, the easiest way to get y-intercept is, of course, slope-intercept form. So I'm going to multiply it out over here. This is going to be 2x minus 10. I'm going to subtract the 3 from each side to get rid of that. I have y equals 2x minus 13. So here now the y-intercept is going to be option A, which is 13. Right? So that's all we got to do for that one. All right, so that's all I wanted to cover on that one, Betty Ann. Those were actually the only two that I thought were sort of worth mentioning. But you know how the process goes. When I send you your sort of detailed breakdown of your grade after we're done here, I'll send you this as well. But now to keep using the same sheet, I'm going to do a bit more stuff for your courses. So this is going to be 1101C Unit 3. And you did ask for some questions on that review sheet. So I'm going to bring that guy up. Let me see. Is this the one? Yeah, this is it. Oh, sorry. Sorry, it's not Unit 2 and Unit 3. My mistake. My mistake. It's Unit 1 and Unit 2. Whatever. That's not a. It's not the biggest deal in the world, is it? Anyway, I know this one says Unit 7 for whatever reason, but I think that's because it's Unit 7 of the program thus far, right? So, and you asked for question 1, so I would like to go through and do that one. Without solving, determine how many solutions each of the following systems of equations have. Now, I'm not wild about how it says without solving. I think I personally, I don't want to restrict the way students do questions like this very often, simply because I think like pedagogically, like from a teaching standpoint, um, it's generally best to just let students do whatever method they think will work best, because that shows, adaptability and an ability to sort of use the tools that you have at hand. Good morning, Esther. Thanks for dropping by. The Kevitt. Oh, welcome. What kind of math is this right now? What level is this? This is grade 10 academic, the end of grade 10 academic in Canada, or the Newfoundland curriculum, because Canada doesn't have a set federal curriculum. We have provincial curricula. Right, but this is systems of equations that I'm working on right now. So for question 1 here, like I said, it asks us to determine how many solutions each of the following have. So really what that's asking us to determine is if the lines are, if they're intersecting lines, if they're parallel lines, or if they're the same line, right? Because intersecting, so this is what we really need to know to start solving this. Intersecting lines have one solution. Parallel lines have 0 solutions. And equal lines have infinite solutions. I understand you had to do this kind of math too right now. Well, great. Yeah. You're welcome to hang out, and hopefully you get some benefit from it. You can ask me any questions you like, and if I understand the topic that you're, or if you're able to tell me what stuff you're working on, I can definitely help you with stuff as well, right? I just have some stuff queued up for my students to get to, and we'll be going over systems of equations for a little bit here. So for 1A, like I said, basically what we're trying to determine is if these lines are intersecting, parallel, or equal. Now, where we're dealing in the grade 10 ones here, we're dealing only with straight lines. Therefore, we're only going to have 1, 0, or infinite solutions, right? We're never going to have 2 or 3 or anything like that. Later on, you will see situations where things can have 3, 4, 5 different solutions because some lines will curve, right? But for now, we're not dealing with any curves whatsoever. It's only linear. So for this first one, we have a half x plus a half y equals 5. And then we have 3x equals negative 3y plus 10. Okay? Now, the easiest way to determine if these are intersecting, parallel, or equal is going to be to put them in the same form. So here we've got an ax plus by equals c. So I'm going to rearrange this one. Oh, we're a little bit, I got to zoom out a touch. Basics right now of Math B, modulus functions. Oh, you're doing mod. Okay. Yeah, we actually don't do mod in this program for whatever reason. I am familiar with those. Like you're basically like counting by threes or by fours or whatever, right? But yeah, for whatever reason, the Newfoundland high school program doesn't actually bring in mod. It's odd though, because that is a useful one. Look at your direction coefficient if they are parallel, right? You make them all y equals a value. Sure, yeah, we can absolutely put them all in slope-intercept form. That is my personal favorite way of doing it. For these ones here, I'm going to do it a little bit more quickly, say for these guys, because I'm gonna put them in to be the same form. So I'm just gonna, on this one over here, I'm gonna move the y's over, and I'm gonna have 3x plus 3y equals 10, 1.5x plus 1.5y equals 5. I think from here now you can already see where I'm going with this. I'm also now going to make it so that the coefficient on the x is the same. How about I just multiply both these sides by 2? We end up with 3x plus 3y equals 10. Right? So we can see here now that these lines are infinite, our lines are equal, therefore there's going to be infinite solutions. Right? Now I did that one a bit more quickly because this question over here is A. This was sort of set up to be able to be done more quickly. That's why they have it be fairly, I think this one's fairly obvious. Like once we move this part over, once we get to this point here, right, this and that, it starts to become pretty obvious that those two are equal. But so for part B, I'll do that one, and then I'll just, instead of doing it like this, I'm going to put it into slope-intercept form, and then we'll see again at a glance, basically, right? So we have 3x minus 5y equals 15, and we have 6x minus 10y equals 20. So I'm going to rearrange these guys to then be in slope-intercept form, like we said. So that's going to be y's by themselves. So here I'm going to call this 3x minus 15 equals 5y. I've just kind of moved these two guys across. Then I'm going to divide both sides by 5. We'll get 3 over 5x minus 3 equals y. This one over here, I'm going to do the same sort of deal. 6x minus 20 equals 10y. That's going to be 3 over 5x minus 2 equals y. Hey, now, look at that, right? That's what we were just talking about, isn't it? Let me grab a different color. But we see now that the slopes are the same, right? Those two are the same, but the intercepts are different, right? Since the slopes are equal, but the y-intercepts aren't, the lines are parallel, and therefore zero solutions. It's going to use oh, gone off the page again a little bit. Let me zoom my cam out a touch again. Oh, we're a bit off square today on my camera. There we go. That'll do. So there we go. Slopes are equal. Actually, let me. It seems like every time. Yes, that is true. For whatever reason, every day I get on here and I set my brightness a bit higher, and then the brightness just goes back down lower afterwards. I don't understand. There we go. That's a bit better. You can see that a bit better. So, since the slopes are equal, but the y-intercepts aren't, lines are parallel, therefore have zero solutions. Are you looking at if they cut each other how many times? Sorry if this sounds a bit silly, but English is not my native language. Hey, no, your English seems excellent. The Kevit? Hope I'm saying that right. The Kievid. Kievid? Okay. Yeah, so that is exactly what we're looking at, yeah. And if they cut each other how many times, that's a good way of phrasing it, for sure. If we were looking at curved lines, like say, let me grab another sheet of paper actually. So if we were on a later course and we were looking at, say, the combinations of parabolas like this with straight lines, then we see those ones can cut, say, twice like that, right? So we have linear lines that can only cut one time if the slope is parallel. They're the same or infinite. Yeah, those are the three solutions, exactly, right? So if we had parabolas like this, if we had curved lines, they can start crossing more than once. Or say if we had a cubic, right? So a cubic looks like so. So if we have one like that, you can see a cubic and a linear can cross 3 times. Cosine waves, yeah, a cosine wave can cross a line an infinite number of times. That's right. So if you had a sine wave like so, right, because a sine wave keeps on going in both directions and keeps curving, a sine wave can either have an infinite number of solutions because a line can cross like that, or it can have, say, one solution if a line crosses like that, or it can have no solutions if a line is up there, right? But for now, for this course, exactly just this one that I'm working on today, we're only dealing with straight lines. So straight lines either have one solution because they're like that, they have zero solutions because they're parallel, or they have an infinite number of solutions, well, just because they're the same line, right? You're welcome. Can definitely explain any of those, and that's very beneficial to my students as well to talk about that because the students in the courses I'm teaching, because we do get on to talk about um, quadratics and cubics. We don't do much about quartics or bigger, but we do up to cubic, and that is, I believe, in the grade 12 academic. So let me just let me just carry on. Um, yeah, I'll do one more of these. I'll do question C here. And then Betty Ann, I think that might be good for this question. If you want me to go over any others on this activity, just let me know. Maybe I'll pick one or two out of question 2 and do as well. Yeah, know a bit of math and doing physics in your free time. I'm going to do the full honors math B to get into university with an exact science. Nice to see you never had to do these kind of things. Yeah, this is it's a really good way to prepare for sure. Like look over other math curricula just to see what you might have to do. Say if the college or university that you want to apply to does a math placement test. I know the one I went to did one, which means when you first enroll, you had to do a test just to see where your math skills are at currently. So let's see here. So number C, 2x plus 7y is equal to 7. Then we have 2x minus 7y is equal to 14. Now these both look fairly similar, don't they? These look like maybe they're gonna always best to read around the subject. Yeah, absolutely, absolutely. It's always good to get a sort of a comprehensive understanding of what you're doing for sure. I'm just going to go down with this one here. 2x minus 14 equals 7y. So then 2 over 7x minus 2 equals y. And this one over here, I'm just going to go over this side. Don't mind my notes being a little haphazard. 2x minus 7 is going to equal negative 7y. Right? Yep, that's right. So then negative 2 over 7x plus 1 is equal to y. Right? So unequal slopes. Therefore, one intersection. It doesn't matter really what the y-intercept is for this question, because if two lines have different slopes, then they're going to cross. So when questions say determine without solving, am I still required to do the work on the test? No, if this exact question was on your test, no, all you would be required to tell me is if there's one intersection, 0, or infinite. Yeah, just figure it out and answer, right? So you can graph it if you want. Like if you had, this guy here, you could press y equals, go up here, and then plug them in, right? Like if I plugged in, now you've got to get them in y equals form for this to work. So let's do question D. I'm going to do question D on my good pal TI-84 here. So D is, this is negative 3 over 4 x, right? And you got to use this one for x. Negative 3 over 4 x plus 6 is one of the lines. I'm going to go down. And then we'll have 3 over 4 x plus 6 as the next one. The graph calculator feels like a hack for your test. Yeah, it is. It absolutely is. These graphing calculators can do a lot, let me tell you. So I'm going to go up here to trace. Now trace is, show you here, trace is this button. So now we're going to see the line. There's one of them. There's the other one. And look at that. We can see that they cross once, right? We can even find out what the intersection value is if we want. I go second function this one to bring up calc, right? Go down here to intersect, like that. First curve, that one. Second curve, that one. They're lines, but you know, the calculator will call them curves. We'll let them off with that. And there's the intersection. Yeah, x is 0, y is 6. So the calculator can do a lot of the heavy lifting for us on a test for sure. But um, one way we could have seen from the start that these were going to have one intersection is because the slopes are different, right? So for part D, we're told from the start that one is negative 3 over 4 and one is positive 3 over 4 for the slope. So since the slopes are different, unequal slopes, therefore one intersection, right? Work complete. Time to do some more work. Yeah. This is yeah. Welcome to the best way to do work for sure is to like watch somebody else doing it. Oh boy, that's the good stuff, right? I love work. I could sit and watch it all day. Solve each of the following systems is what it says next. So let's those ones say solve by graphing. Those ones give us a word problem. Okay. Okay, sure. So let's do Betty Ann, I'm going to do say two of these ones, and then I'm going to pop down and do a few of the word problems because word problems are definitely going to be on your test. Let me zoom in a little more. Actually, seeing I can zoom in this much, let me flick back over to my other display. Here we go. There we go. So solve each of the following. Might sound basic. Do you have some advice on how to approach math questions? Sure. I'll tell you what. Just hang out a little bit. I'm going to do two of these guys. Then we're going to see how to do some word problems. Maybe that will help you understand sort of some general ways to approach it. I like to declare my variables, to write down sort of, and that's a physics background as well. I have a bit of a physics background, and yeah, declaring your variables or writing down everything that you know when you're starting can help you sort of approach a math question, right? This is still math 1101C, and this is unit 2. This is going to be 2A. I'm going to do 2A here. So this one just tells us to solve. So we can solve this however we want. So I am going to solve these ones. Yeah, I'll do two different methods. So let me do 10x minus 8y is equal to 51. Yeah, I'm going to make this hard on myself. I'm gonna make it hard on myself. I'm gonna do this one with substitution method. The reason I'm saying why this one is harder is because it's already kind of set up for elimination method to work, but we'll show elimination method for 2e, I think. So substitution method, what that means is I'm going to rearrange one of these equations to get one of the variables by itself. So I'm going to rearrange to get x by itself. So I'll call this one negative 6x is equal to 8y minus 5. So this sort of negative 8 moves over and becomes a positive 8. Then I'm going to divide each side by this negative 6, and I'm going to have x is equal to negative 8 over 6y plus 5 over 6, right? Or I could go ahead and call this x is equal to negative 4 over 3y plus 5 over 6. Okay? So now when we have substitution method, what that means is we take this value and we substitute it into the other equation over here. Always has to be the other one. If it's the same one, we're going to end up with something silly like negative 5 equals negative 5, which is true. I mean, it's true that negative 5 equals negative 5, but it's not super useful for us. But now what I can do is I can take this equation here, and instead of x, I can write in this. Looks like a bit of a monstrosity because we're sort of making the question more complicated, but you'll see that it's going to work out fairly well. Right? So now I'm going to multiply this out. I'm going to have negative 40 over 3y plus 50 over 6 minus, instead of calling this 8, I'm going to call this now 24 over 3y equals 51. We're going to go ahead and subtract these guys. This will be negative 64 over 3y plus, I'll call this 25 over 3. It's going to equal, well, 51 is the same as 153 over 3. I'm going to just write it out, all of it out as over 3 to save myself a little bit of work here. I think most of the time I would know how to solve things. It's just what they're asking of you that is the difficult part of math. Absolutely, it is for sure. Yeah, yeah, you're definitely right there. It is the hardest part of teaching math too, is sort of making it clear to students which part of what we're doing is like learning the language and the diction that this specific textbook uses or this teacher uses versus which parts of it is understanding, the fundamentals behind it, right? And especially with word problems, that can come out. I'm going to go ahead and subtract now. Negative 64 over 3y is 153 over 3 minus 25 over 3. Seeing this in English makes me realize that more. Yeah. Yeah, probably so. Yeah, absolutely. Excuse me for a second. So, negative 64 over 3y is going to equal, the minus 25 is going to be 128 over 3. You notice I'm just leaving it as over 3 for now, right? I could have, at this stage here, because I had the same denominator for all of them, I could have just canceled all the denominators in total. I didn't, but, I could have. Now y is going to equal 128 over 3 multiplied by negative 3 over 64. These are going to cancel, and this is going to become a negative 1. 128 over 64 is, I believe, 2. Indeed. Indeed it is. So that's a 1, and that's a 2. So y is actually equal to negative 2. Boy, that was a really roundabout way. That was a scope, as my mother would say. Um, that was a really roundabout way to get to a fairly simple answer, wasn't it? Y equals 2. But that's because I picked substitution method in a question where it seems like it was set up for us to use elimination method. But anyway, now that we have y equals 2, negative 2, we can go plug that into either of the other ones and we'll get our answer. Negative 6x minus 8 times negative 2 is negative 5. Negative 6x plus 16 is negative 5. Negative 6x is going to be negative 21. X is equal to negative 21 over 6. So x is going to equal, negative 21 over negative 6, right? Which is going to be 21 over 6 is the same as 7 over 3, right? No, 7 over 2, sorry. X is equal to 7 over 2. And there we go. So that'll be your answer for 2A. Although, Betty Ann, I imagine that if you're doing this one on your paper, you're going to do it as elimination method instead, because it's already set up with the same coefficient on the y's. So if you have the same coefficient on the y's, you can go ahead and do elimination method right from the get-go. I'm going to do one more question from this section. It's going to be I'm going to do 2e here. So now we've got 2x plus 5y equals 6. And we have, I'm going to do this one in 2 different colors. So I'm going to alternate here. I'm going to have 3x minus 2y equals 1. Okay, I'm going to do these guys in 2 different colors because I am going to do now elimination method. There we go. So what elimination method means is we're going to get either the coefficient on the x's or the coefficient on the y's to be equal. And just like a fraction, right? Like in a fraction, we can multiply the top and the bottom of a fraction by the same thing, and nothing happens, right? In the same way, in an equation, we can add something to either side, and as long as it's the same thing, we're doing it to both sides, we're fine. We can also do it with multiplying as well. So here what I'm going to do is I'm going to multiply both sides of this and both sides of this by a number so that the coefficient on the x's I'm going to pick to be equal. So what I'm going to do is I'm going to multiply this side by 3, and then also this side by 3, right? So I'm going to end up with 6x plus 15y is equal to 18. Over here then, in my blue one, I'm going to multiply both sides by 2, right? Then I'm going to end up with 6x minus 4y is equal to 2. Now that I have this, I can put them both together. So I'm just going to move this guy over and write this down below. 6x minus 4y equals 2. I'll just draw an arrow over to show that I just moved it over like that. Okay. Now, what I'm going to do is subtract. So in elimination method, I'm going to subtract this whole equation from the one up here. Now, I know before you do systems of equations, you might not think that you could even do that, right? But you can. Since we have two equations where we know the x's and the y's are the same, we can actually subtract the full equation from the other one, or add it, depending on what we need. But because we have a positive 6x and a positive 6x, and I want there to be 0, I'm going to subtract. So we're going to be left with 0 x's here. I won't write that in. Subtract a negative 4y is going to be a positive, so it's going to be a 19y. And then we're going to have 16. I think that is right. Yeah, that's right. Then we're going to have a 18 minus 2, which is going to be a 16. So y is going to equal 16 over 19, which is a bit of an odd number, right? But that is what we're getting here. As long as I didn't make any mistakes. Could you also divide it by 6x? Now, dividing by 6x, if we divided both sides here by 6x, we would still have it we would have x's on this side then, right? So just to show you what that would be like if we had, say, 6x plus 15y equals 18, and I was to divide both sides by 6x, what we would end up then with is a 1 plus 15y over 6x equals 18 over 6x, right? Right, because everything is 6x underneath, exactly, yeah. So it would go away here, this would become 1, then we would have x's here and x's here still. Right? If we do it this way, the point is to eliminate all of the x's, and then we end up with y equals 16 over 19, which I'm just checking to make sure I did my math correctly, because sometimes when you get an odd fraction like that, it sort of psychs you out a bit. But as far as I can see, everything was done right there. So yeah, y equals 16 over 19. So then I'm just going to take this and substitute it back in to one of the other ones. So we'll say 3x minus 2, 16 over 19 is equal to 2. 3x minus 32 over 19 is equal to, I'll call this 38 over 19, because that's the same as 2. 3x is equal to, this is going to be then, it's going to be 70 over 19. So then x is going to be, divide both sides by 3 is going to be 70 over 19 times by 1 over 3. Boy, so x is going to equal 70 over 57. Yeesh. Okay, that was a real, that's a real mess. Those are some fractions for sure. We get some, I believe 70 over 57 can't be reduced down. 57 is the same as, that's 19 times 3. 19 and 3 are both prime. So I think that's as much as we can do there. 70 is, of course, 7 times 10, or 14 times 5. Neither of those can go into 57. So yeah, looks like we're done with that one. Ah, Slayer Darth, going over your notes from yesterday's stream on calculating percentiles. Oh, cool. Yeah, we're gonna I am going to mention percentiles again today, actually. That'll be that's what Esther is working on currently. I do want to review a bit of what she did on that topic. So we will get onto that in a bit. Your calculating is what point they will cut. Exactly. Yes. Just to bring it back up there. Yeah, so this is now what we call the POI, or the point of intersection, is going to be 70 over 57, comma, 16 over 19. And those are simply just those are the exact fractions for it. You could put it into a decimal, but then you'd have to round, right? So I'm going to leave it as a fraction. So now I will, let's see, I'm going to slide down and do some word problems from the next section. Now, word problems need a bit more space to look at, so let's move over to this display. There we go. We need to zoom out a little bit more. There. Okay, good. For each of the following word problems, set up a system of equations and use it to solve each question. Okay. Oh, 1101C. You'd think I'd remember, right? You'd think that. Number 4, let's do 4A. She's really handy if you need to calculate an equilibrium. Yeah, for sure. Although a lot of times, if you needed to calculate it for a reason other than a math test, you'd probably, use a calculator. Or you'd use, if you don't have one of those guys, you'd use Desmos.com or something like that, right? You'd use this over here, which is a super duper useful calculator, right? You can just, you can go get that one online. I'll move my head out of the way so I'm not blocking the shout out there, powered by Desmos down in the corner. But for now we are going to use systems of equations like that because, that's what the course is. Or do it by hand, rather. You would use systems of equations with a calculator too. You just plug them into the calculator instead of having to solve them with elimination or with substitution. Anyway, so the school that Stefan goes to is selling tickets to a choral performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. It took in 52 on the second day by selling 3 senior citizen tickets and 2 child tickets. Find the price of a senior ticket and a child ticket. Okay. So this is an example of one where we're going to need to first figure out what it is that we know. So I'm going to say S for senior and C for child. So we know that 3 senior tickets, right, and 1 child ticket. So in 1 child ticket, we know that those make $38. Then we know that, let's see, 3 senior citizen and 2 child. Huh. That's easy. So 3 senior citizen plus 2 child is going to give us 52. So they're really taking it easy on us with this question, right? Because if I go ahead and just use elimination method, I'm just going to go ahead and do that. We've already got the same coefficient on the S's. Look at that. You can even just see from a glance that it's going to be $14 per child ticket, right? But anyway, let's go ahead and do the subtraction and show out why. So 3S minus 3S is going to be, of course, 0 S's. I'll write it in there just so you can see. 1 child minus 2 child is going to be a negative 1C. Now I know it doesn't make any sense to think of like negative tickets, but just bear with me for now. It'll make sense once we're done. 38 minus 52 is a negative 14. So then, of course, C is equal to 14 because I divide both sides by the negative 1. So there we go. So then I know that 3 senior citizen tickets plus 1 $14 child ticket is going to make 38. So 3S plus 14 equals 38. 3S is going to equal 24. So we know S is going to equal 8 once we divide. Right? That's all you got to do there for 4a. That one was deceptively easy, actually. Let's see if there's a harder one here. Uh Betty Ann, if you're still watching and you've got any specific ones you want me to do, just let me know. Okay, I'll do C and then maybe I'll do F afterwards. So for question C, at a restaurant, the cost for a breakfast taco and a small glass of milk is 2.10. So, all right, so taco plus milk is 2.10 milk. Three tacos and three small glasses of milk are 5.15. So two tacos plus three glasses is 5.15. Okay. So now in order to do a elimination method, I'm going to have to rearrange one of these guys. Excuse me. I'll do a substitution method. So to substitute here, we can call this t is equal to 210 minus m, right? So I'm going to do a substitution over here. Just to show, again, the second, or both methods. Substitution often ends up being a bit more work than elimination, but the difference is substitution always works. Elimination is kind of a shortcut. I mean, not we can always get the coefficients to be the same, but sometimes it's way more work to do that. Anyway, so t is equal to 210 minus m. So 2 times 210 minus m plus 3m is equal to 515. Right? So then we have 420, LeMayo, minus 2m plus 3m is equal to 515. So we have m, because minus 2m plus 3m is going to be 1m in the end. M is going to equal 515 minus 420. So m is going to equal, what is that, 95 cents. Right? So now we know that the glass of milk is 95 cents. So then we have t plus 0.95 is equal to 210. T is then just 210 minus 0.95. So t is equal to $1.15. I don't know where they're shopping to get these kind of prices at a restaurant, but $1.15 for a breakfast taco sounds pretty good to me. I think a breakfast burrito is more than that at McDonald's even. Okay, but that is, yeah, those are the answers there. So that was with substitution method. I'll go ahead and do question F on here because F has a little bit of a wrinkle in it that the other ones don't. I'll go ahead and do this one in green. Question F then. Marcos had 15 coins in nickels and quarters. Of course, now this one requires you to know that a nickel is 5 cents and a quarter is 25. I imagine my students would know that, but someone who's not from the US or Canada might not know that. Because Canada has quarters as well, whereas, say, UK does not. They have 20 PE coins. I'm not sure what other countries have, like Australia. I don't know. I haven't been to Australia. Marcos, he has 3 more quarters than nickels. Oh, okay. This is cool. So we know that the number of nickels plus the number of quarters is going to be 15, right? Because it tells us that first. So Marcos has 15 coins in nickels and quarters. Europe intensified? Yeah. Exactly. Europe intensifies. Yes, we get some Eurobeat going. Maybe I'll play some Franz Ferdinand or something. I don't know. Does that count? They're British, right? Maybe. I don't know. I don't know music. What is this? I'm a math streamer, not a music streamer. N plus Q is 15. Has three more quarters than nickels. Guys from the Vaterland, from the Netherlands. Okay. Oh, great. I've been to Netherlands. I've been to Netherlands several times. Only to Amsterdam though. I was Amsterdam three times. Yeah, when I was because I lived in England for a few years. So n plus q is 15. Sold cocaine to both sides of World War One. Oof, big oof. N plus Q is 15. Yeah. Although, yeah, Netherlands, right? Canada. Yeah, we've got that little. We get tulips every year sent to Parliament Hill from the Netherlands, which is beautiful. We love seeing that every year. I don't live anywhere near Ottawa, but we see pictures of it, and it's because of Canadian soldiers liberated the Netherlands in World War II, right? Which is a little feather in our cap. Very, you know, Canada's proud to have been able to help out in the past. We still we teach we definitely remember our history in Canada. That's a very important topic in school. Um, three more quarters than nickels, right? So quarters, three more quarters. So quarters, crap. I should write it out the other way. This is a better way of thinking about it. N plus three is Q, right? Because the number of nickels plus three is the number of quarters he has. So that's sort of the tricky part there to remember, right? Or to interpret, because it says he has three more quarters than nickels. So the number of nickels plus three is going to give us the number of quarters. So now we've got it set up already that we can go back and just do elimination method right away. Can you post a link in chat? Sure, sure. I would recommend people not click it, but I don't think AutoMod will get you. No, I don't have that set up yet. So let's see, n plus 3 is equal to 15, right? Because we know that n plus 3 is equal to q, so we can substitute that one into here and get this. So we have 2n is equal to 12, so then n is equal to 6, right? Now once we have n is equal to 6, we can go ahead and solve the next bit. Really good open source textbook used for free when learning algebra from scratch. Okay, cool. Yeah, it's clearly a PDF link. Yeah, maybe I might check that out later. Different types of word problems and exercises. Great. Yeah, it's good to have those resources for sure. So we have 6 plus q is equal to 15. So then q is just going to be equal to 9, right? All right. So Betty Ann, hopefully that was some useful review for you for that topic. I'll send you the notes when we're done here, and a link to the video so you can, bounce around from point to point if you need to review any specific parts. For now, then, let me just zip on back over to my intro screen. Stream starts soon. Nope, it's already going. So 1101C test review sorted. So the next one, um, let's see, Unit 3 test review, 1102A. Okay. Actually, Esther, you were in chat already, weren't you? You already sounded off in there. So tell you what, yeah, I'll switch the order of these. I'll do 3102A Unit 2 recap here now. So Esther, if you're hanging out, I'll go get you that one done there now, because I wanted to do a few questions quickly out of this one that are ones that I think are good teachable moments from the activity that you just did in that course. So let me switch on back over here now to actually we'll do it on my document display because then we can see it a bit bigger. Oh, you're still there? Okay, great. Okay, yeah, so I will do the material for your course there now. I've got the grade and everything for the activity that you did. No worries about it. You did fine. You got through it. So I'm just going to go through and do out a little bit of questions about it here now. This is math 3102A Unit 2. Now, I'm going to do questions 4, 6, 10, 11, and 13, I think. But these are quicker. These are a bit quick. So what is the median for the following set of data? Well, remember now, whenever we're doing a median, we've always got to put the numbers in order first, right? So we've got a 35, then another 35, then what's next? 67, 74, 80, 84, 87, 90, right? 1, 2, 3, 4, 5, 6, 7, 8. 8 numbers there. And is it 8 numbers over here? Is my cursor coming up? It's not. 1, 2, 3, 4, 5, 6, 7, 8. Okay, great. Good stuff. Okay, so what is the median? Well, all we have to do for the median then is find the middle number. But here, of course, we've got 8 numbers. So I'm going to do my n plus 1 over 2, which is going to be 8 plus 1 over 2, 9 over 2, which is going to be 4.5. So when we see a 4.5 from our handy dandy little shortcut method to figure out which number we're doing, this means we need the number that's in between the fourth and the fifth number. So we're looking for the number in here, whichever one is in between 74 and 80. You might be able to look at that and tell that it's 77 right off the bat, right? Because it's halfway between. The way we're going to find it, though, is 74 plus 80 divided by 2, which is going to be 154 over 2, which is, like I said, going to be 77. So we know that this one is answer D, right? And the important part there is to put them in order, but also to remember that when you see the 4.5, that means the number in between here, right? Number 6. I'm just going to go through some of these, like I said, some of these fairly quickly here. In this data set, what represents the 25th percentile? Now, thankfully, we already have these ones in order, right? So because we have these in order already, we have 12, 15, 17, 21, 28, 30, and 40. We know the 50th percentile is going to be the median, right, which is the middle number, which is 21. So the 25th percentile is going to be the median of the lower half of numbers. Now we're going to do the lower half not counting the median here. So we're just going to do the median of these 3 numbers. And the median of those 3 numbers is just 15, right? So it's going to be option A for that one. Excuse me. Okay. This is a good one. Yeah, I wanted to go over number 10. So number 10 here is the trimmed mean, the following data set. Okay, I'm going to keep alternating my colors. Yeah, Slayer Darth. Yeah, it's a good tip there, right? That is exactly what we're needing to do here, right? So trimmed mean for the following data set. And that's a lot of numbers. I'm going to write them out in order. Well, I'm going to write them out like they are there because I don't have a copy of this on paper. My printer is out of ink, and I'm remaining socially distant, so I'm not going out and getting more printer ink. $42 and $50. So now I'm going to put these in order. So the lowest number here looks to be 16. I'm going to cross them off as I'm doing them now, which is why I wanted to write them out. It's like 32 is next, then 42, then 50, then let's see, 58. Well, looks like there's two 64s. There is a 72, 75, 76, 81, 83, 92, and 100. Let me just count and make sure I've got the same number of numbers again. So let me go over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14. Okay. So I'll do the Google Mobile. Great. All a trimmed mean means, mean. A trimmed mean is just we cut off the outliers. Now, trimmed mean, we're not necessarily just cutting off the outliers because a trimmed one is we cut the same number off of both sides, hence the trimming, right? So this is the full set of numbers, all these guys. And then trimming is just we cut this guy out and cut this guy out. Now, if you're a Newfoundlander like myself and an older person tells you that they're going to trim you, you better watch out. You better start running because that means you're in for a spanking, maybe with a belt. If you're in for a trimming, right? You don't want that, right? Esther, you might be familiar with that terminology. But in math, when we trim things, we're taking an equal number of values from one side or the other, right? And getting rid of those. Now, Esther, I think you did the method correctly here. Outliers are numbers that deviate too much from other numbers in the set. Yes, in general, yes. Outliers are ones that are much higher or much lower than others. But for trimmed mean, like I said, we're going to take the same number of numbers from both sides, right? So here I'm going to cut off one on this side, so I'm going to cut off the 16. I'm going to cut off one on this side, which is the 100. And Esther, like I said, I'm pretty sure you did this one correctly on the sheet that you had there. There might have just been, I think, maybe a small like transcription error. Maybe one of the numbers got added together wrong or something like that. But you definitely showed that you know the working for these ones. All right, that looks like all of them there. 789. Is that right? Let me just tell you what, I will model good behavior here. I'm going to try that again because I'm not 100% sure that I did it correctly. And it's always good, especially on a test scenario, especially, to add your stuff twice. I know it's a pain, but, transcription errors, just punching in the wrong number or whatever, that can happen. Easy, easy, easy. So there we go. 789, that's right. 789 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 789 divided by 12 is going to be, 65.75. 65.75, or we'll call that approximately 66. There we go. So that is option C. Have to go. Thank you for streaming. I learned a lot today. Oh, you're very welcome. Yeah, thanks for dropping by. The Kevin. I hope I'm the Kevit. I hope I'm pronouncing that correctly. Yeah, feel free to drop by any day you like. I'm here 5 days a week. I start streaming at it's 1 p.m. Newfoundland Standard Time, which is 11:30 Eastern. Which, if you're in Netherlands, I believe you're 4.5 hours later than Newfoundland. So I think it should be 5:30 p.m. for you that I start. How do you calculate the trimmed mean if a percentage is not provided? Well, the trimmed mean doesn't really deal with percentages. 0 new cases again today? Well, that's great news. That is great news, Esther. Thank you. Thank you for dropping in. Thank you for dropping that bit in. I usually check after we're done here, but yeah, we've had 2 weeks now, solid 2 weeks of 0 or 1 new COVID-19 cases in the province. It's great. It's great to see that. Our social distancing is doing really well. But yes, Slayer Darth, if a percentage is not provided, well, the percentage isn't like the important part. The important part really is just that we know that we've got uh, this many values. We've got 14 values, and if we're going to trim it, we're just going to take one value from either side, or you could take 2, or you could take 3, right? But of course, the more values you get rid of, the more you're going to affect your answer, right? But the idea is just that instead of picking certain values to be our outliers, we just say a blanket statement that we're going to cut 2 off of either end in order to get rid of some of the outliers on either end. right? Let's see. I wanted to do question 11, and then I want to do question 13. Okay. Restrictions getting revamped tomorrow, possibly. Oh, cool. That's good to hear. Yeah, I like that. I like that they have Dr. Ramen on there as well. Dr. Proton Ramen, who is apparently he has the greatest name in the world. Proton Ramen. That's amazing. But also he's a yeah very celebrated, very well known statistician apparently, and data analyst. So it's great that it's great that we've got people from the university who are able to give us these very meaningful sort of reports, and we've come in under all the predictions so far. So I know that they wanted to be very careful about the predictions that they made, and not get people's hopes up too much. But I think from what we can see, we've done really well here. So I think everyone on the island, or everyone in the province rather. I don't mean to exclude Labrador. Everyone in the province should be proud, I think, of the way that we've responded to this pandemic. Um, let's see. So number 11, science experiment was performed to measure the effect of fertilizer on tree growth. One of the 70 trees did not grow at all, while the rest of the trees nearly doubled in height. Which of the following best describes the data? Right. Okay. The reason I wanted to bring this one up is because I do like to talk about how one of the main things um, in statistics is sort of understanding the reasoning behind or understanding the logic behind what we're dealing with, right? Because statistics, sort of the conceptual interpretation of what we're doing, has to go hand in hand with the math that we're doing, right? And in this case, we say, what do we know based on the fact that one tree out of 70 did not grow, whereas the others doubled in height, right? Is the mode very valuable in this case? Well, we have no idea. We have no idea if the mode is valuable, and generally the mode is not valuable at all when it comes to something like measuring heights, right? Because like say it was 20.1 centimeters versus 20.12 centimeters. Is that the same for purposes of the mode, or is that different, right? So when we're measuring something as opposed to counting it, the mode is generally not super useful. So we can write A is not the case. B, the data set contains an outlier. Well, that's true. We know that for sure. The one that didn't grow at all is definitely an outlier. So B could be the answer. For C, the data set shows that one of the trees was diseased. Now, the problem there is that it might have been, right? That might be the reason why the tree didn't grow. But of course, from the stats that we have, we can't tell that, right? That would be sort of reading into the statistics, and it's not actually what the stats are telling us, right? Right now, actually, with COVID-19, it's a really good time to be thinking about, knowing the limitations of what stats can tell us and what they can't, right? We can infer that maybe this tree had a disease, but we have no way of knowing that for sure. So C is also not one that we can choose for an answer here. And then part D, the data set is not useful. Well, all data is useful. That's foolish. Data set is not useful. All data is good. Data is always useful. So the answer here is definitely B. It contains an outlier, but we don't know why yet, right? Could be any reason. We have to do more tests. We have to look into stuff a bit more to figure out why. But that's just that one's more of a conceptual question, but I do like to bring those up as a teachable moment because it is definitely an important thing to know. Right. I think actually, yeah, I think that's going to be good for those questions for today, Esther, for yours. I have a little bit that I went over on stream yesterday as well. That was on your work. I will send you the link to both videos after we're done here today, right? And then I'll also send you the grades and stuff on the activity that we're talking about. Now, Ashley, I don't know if Ashley is watching right now. I'm not even sure if Ashley made a Twitch account or if I know what her Twitch account is, which is probably for the best, right? You might as well keep me guessing. Like if you're one of my students and you haven't sounded off in chat before, so I don't know what your Twitch account name is, maybe you can just keep me in the dark and come on and start trolling me. They're like, why is this person making fun of me? Turns out it's one of my students. Anyway, so that was 2A Unit 2 recap. I said central tendency. Oops, sorry. That was a bit of a misrepresentation of what the topics were going to be. A little bit on central tendency. So now Unit 3, test review, surface area. Right. And that'll be my last topic for today. Spend maybe, 20 to 30 minutes on that, and then I'll have to go resume my other teacher duties for today. Let me see. What was it that I was going to go over? Yes. Okay, these are some good questions I had to go over here. So, Ashley, for yours, I'm now going to go over a few word problems, right? Because we've gone over a bunch of the just normal computation ones, and I think you're getting those really down pat, like using the formulas and all that. So today I want to show just a little bit of a different take on them, and show some of the word problems that you might have to do, right? So these are some examples from your textbook, but your test is likely to contain questions that are pretty similar to this. So this is now math. What is this? 1102A Unit 3. And this is in your notes. This is going to be page, what is this, 161. I'm going to do question 7. Okay. So question 7 tells us that Melanie and Ron are building a greenhouse to grow vegetables. The greenhouse will be shaped like a half cylinder that has a length of 36 feet. The greenhouse has one end that is not covered in plastic. The end of the greenhouse measures 16 feet wide and 8 feet high. What is the area of the greenhouse that will be covered in plastic? Round your answer to the nearest square foot. Okay, so this one, yeah, this one's got some twists to it. So this is a good one to show. Normally, when we have our cylinder, right? So normally when we have our cylinder like so, right? Normally we have surface area is equal to 2 pi r squared plus 2 pi r h. Now I always mention, right? I always mention that this is the top and bottom, or the ends, right? And this is the sides. I always mention that, right? Because for questions like this one, questions like number 7 on page 161, it's super important to know which part of the equation corresponds to what sort of property in the real world, right? So here now, what we're going to have first up is the whole thing is going to be cut in half, right? Because what we're actually dealing with is not a cylinder like this. It's actually a cylinder like this, right? It's actually flat across the ground, and it's cut in half like that. It doesn't matter what the orientation of it is, really, right? But what we've got is a cylinder that's cut in half, like so. So right? So since the cylinder is cut in half, take a half of the formula, right? So then the surface area is going to be a half outside of 2 pi r squared plus 2 pi r h. Now I know I could put that in there and simplify it right now, but just bear with me for a second. I'm not going to simplify it right now because we also have another thing that we know, right? We also know that since one of the ends doesn't need to be covered, we don't need 2 pi r squared. We just need pi r squared, right? Since one of the ends doesn't need to be covered, we don't need this 2, right? Because the reason this is 2 pi r squared here is because we're dealing with the top and the bottom ends, right? Or the left and the right ends when it's over, on the ground as a greenhouse. So we only need one of those. So we actually will have our surface area is going to be a half outside of pi r squared, we get rid of that 2, plus 2 pi r h. Now, now we can go through and sort of find the results here, right? Now this, yeah, too bad the Kevit is not hanging out here because this would be a good answer to the question they had earlier, right? Where here now, what I'm going to show over on the side is how I broach or how I approach these sort of questions, which is declaring variables over here on the side, right? So now I know that I know that the height of this is 36 feet. We get that from over here, right? We can see that. Oh, see that right here. There it is, 36 feet. And then the greenhouse measures 16 feet wide and 8 feet high. Well, it's round, right? 16 feet wide and 8 feet high. Our radius is 8. There we go, right? It just shows some of the weirdness of Canada that we, technically use the metric system, but half the time we're measuring stuff, we use feet anyway, right? Um, so then surface area is going to be a half pi times 8 squared plus 2 pi 8 and 36. So all we've got to do is go fill it all in once we've got it all done out like so. The difficult part of this question is realizing that this sort of was the equation that we needed, right? So then the surface area is going to be a half outside of 64 pi plus, boy, I'm not going to do 8 times 72 in my head. Okay, maybe I could. 8 times 2 times 36, 576. Yeah, maybe not. 576 pi. So then the surface area is going to be a half outside of, that's 580 plus 60, which is 640 pi. So that's going to be, surface area is 320 times pi. So then the surface area is going to be 320 pi, 320 times pi like so, 1005.3. There we go. All right. So that is Math 1102A, Unit 3, Question 7. Wonderful. Okay. So Ashley, if you're watching there now, you can just drop a message if you want me to do any of these other questions. I'm going to do one more here now for your topic, which is useful to us as townies. Although I know you guys are from my students are mostly from CBS, so people from CBS don't consider themselves townies for whatever reason. But you're actually a townie if you consider like CBS and Paradise to not be town. You're a townie, right? Because anybody from DeBay knows that CBS is just a bedroom community of St. John's. Come on, boys. I just made a bunch of people mad. Deal with it, I says, my son. Deal with it, boy. Yes, boy. Yep. Nice, sunny boys. This is now Math 1102A Unit 3 still. Okay. And I'm going to do page 163, question 3. The reason I bring up town is because this looks like the Irving oil tanks, eh, boy? Yes, my son. Right across the harbor on the other side over there. Yeah. That's why I got if you're in Cowan Heights and looking across, boy, not Cowan Heights, no boy. Where's your two? Now if you're downtown, yes, on top of the hill, and you looks across, you get a wonderful view. Yes, my sunny boys, you get a wonderful view of the Irving oil tanks. I'll stop. But 4 cylindrical oil tanks are due to be repainted. This helps prevent them from rusting. Each tank has a height of 20 meters and a diameter of 20 meters. The bottom of the tanks do not need paint. It's the surface area of the exposed portion of one tank. Okay. So we know then that the surface area of a cylinder is equal to 2 pi r squared plus 2 pi r h. And as always, this is the ends and this is the sides. All right? Got to make sure we keep that there. So since one end doesn't need to be painted, we'll use surface area equals pi r squared plus 2 pi r h, right? Because one of the ends is now gone, so we get rid of that one, right? And we know over here, we know that our height, we were told, is 20. Our radius is going to be 20 over 2, which is 10. And those are meters. Right? So that's what we were told from the equation. So now all we got to do is plug these guys in. Surface area is going to be equal to pi times 10 squared plus 2 pi 10 and 20. It's fairly easy. So that is going to be 10 squared is, of course, 100. So this is going to be 100. What am I doing? 110. This is going to be 100 pi plus 10 times 20 is, of course, 200. 200 times 2 is 400. It's going to be 400 pi. Surface area is 500 pies. And we could just leave it like that, honestly. I mean, leaving it as 500 pi is totally good for that. 500, 500 pi, like so. 1570.8, I'll call that. 1570.8 square meters. So now part B just asks us, 1 liter of spray paint covers 10 square meters. How many liters of paint are needed to cover the 4 tanks shown? Well, 1 tank equals 1570.8 meters squared. 4 tanks are, of course, going to equal 4 times 1570.8, which is going to be, right, doing it lazy across there, 6283.2 meters squared. Okay. So now I'm just going to do 6283.2 meters squared divided by 10 meters squared per liter, right? And we're just gonna be dividing by 10 then. We're gonna get 628.32 liters. Round your answer to the nearest liter. Okay. Now here's an example of rounding, right? Now this one I would mark you correct if you gave me 628. I would mark you correct because that is to the nearest liter, but it pays to be thinking sort of conceptually, just like we were talking about the last ones, right? About the statistics ones. It pays to be thinking conceptually because, for example, if someone bought 628 liters and tried to paint this, they'd run out. You'd have a small little part at the end that's not painted, right? So in this case, for the number of things you need to buy, you're going to have the round up. You're going to have the round up, or you're going to be short. You're not going to have enough paint, right? So we should say they should buy 629 of paint, right? Because you want to have, this gives you a little more than you need, but only barely. Because if you bought 628 liters, you're not going to have enough, right? And it's interesting to think about, for me anyway, how in the real world, the rounding that you do is not necessarily based on this hard and fast math rule of, if it's a 5, it's up, and if it's lower than 5, it's down. It's more based on the concept of what you're dealing with. Like my dad works in aircraft maintenance, and he says, when you're fueling an aircraft, you always round down. You always have the round down because it's safe. It's for a safety reason, right? Like if you put, I don't know, say you've got 11.2 gallons of fuel left. It sounds like not very much for a plane, but if it's 11.2, you would have to call that 11, right? Because you'd always have to, or even if it was 11.8, rather, if it was 11.8 gallons, normally you would round it up to 12, right? If you were following the normal math rules. But for a plane, you can't, because as soon as you've done that, you've told the pilot that he has 0.2 gallons more fuel than he actually thinks he has. And over time, those sort of rounding errors will compound, and you could end up being the plane could end up being short on fuel, right? So you in those sort of cases, they always have to round down, like no matter what, you round down, right? In this case, is another. It's less severe, obviously, because if you're short on paint, well, guess what? You're just going to go out to Kent or Canadian Tire or whatever and get yourself a bit more paint. But you still have to pay attention to the fact that rounding is based on context, right? So either way, Ashley, that should be some good help for you there on those topics, right? So that'll be it for today. I'm going to clue it up here now. Um, yeah, thanks for sticking it out. Thanks for coming back and chatting and watching. I yeah, I'm glad to help anybody who wants to come by and has any math stuff to talk about. More than willing to help. And yeah, I'm super happy to hear about our good coronavirus numbers in the province, and that maybe tomorrow we'll have some new news about what's going on. Um, as far as our public health directions go. Right. Well, thanks for being here with me. Yeah, keep working on your math. Keep interested. Stay safe out there. You know, and like Red Green says, I'm pulling for you because we're all in this together. Right. See you tomorrow.